Alright, ladies and gentlemen, so for this second one, this is the stuff that I'm seeing you guys having some struggles with. Now, I might not give you all the answers here, but I do want to definitely give you some help, obviously, to finish this up. But I have been a little disappointed. So, both on this stuff, the exponents, and especially the function stuff, I'm seeing a lot of people doing some either very strange stuff, um, or trying some stuff that you know how to do, but you're not doing some of the things that I'm showing you in the video. And that's kind of showing me that some of you are not watching them. And it's really, really important, because with these can be tricky, but my videos have been giving you some hints as to how to deal with them. All right. So, for example, with these four, there are four problems here. There's only going to be three types of problems. There are three rules you have, and it's these right here. One of them is when you're multiplying terms, they have the same base. When you're multiplying two terms, they have the same base, you add the exponents. There's no parentheses. You just add the exponents. When you're dividing terms with exponents, again, same base, the twos, you're subtracting the exponents. And when you see parentheses, an exponent to an exponent, you're multiplying those exponents. There's only three rules. All you have to do is identify which rule you're going to use and then follow it correctly. So what I mean is this. Look at the first one. Y to the fourth in parentheses to the third. It's parentheses. So automatically, three rules. Only one of them has a parentheses. Only one of them has an exponent up to another exponent. You're going to multiply your exponents. So for this one, you're multiplying 4 times 3. And they are exponents, so they stay as exponents. All right, what about the next one? It's division. There's only one rule that involves division. It's this one, and that is where you're going to subtract the exponents. Now, just be careful. The numbers here are separate from the numbers or from the exponent. They're separate. I'll even put a little times there to help you out on that one. Okay, numbers still divide like numbers. 6 divided by 2, you're not all of a sudden going to subtract. Nothing changed. 6 divided by 2 is still 3. The only difference is what I'm about to box in red. This with exponents is what we're going to use our rules for. And here you're going to subtract the exponents. 7 minus 4 is 3. Subtract the exponents. Identify the rule. There's only 3 of them. One of them has parentheses. One of them's division. And the last two are multiplication. Those ones are being multiplied. That's this one. There's no division. There's no parentheses. It's multiplication. And in that case, you're going to add the exponent. So here the exponent is 8. And over here, again, the 2 is separate. 2 times 2 is still 4. You don't add them all of a sudden. Nothing changed. 2 times 2 is still 4. And then you add the exponent. All right. I don't know if you need to pause it here for these rules to remember them. Take a screenshot, write them down, something. There's only 3 rules. Identify which one. And I'm not combining them. I'm not putting them together. It's just those 3 rules. You have to pick which one, and then you do it. Now, with functions, I can make it very simple for you. You are looking at the x's, and you cannot have repeat x's. So for a table like this, here are your x's, here are your y's. Each x can only have one y. So what I mean is that when I plug something into the machine, so I'm going to plug a -1 in. I get a -2. I can only get that -2. If I plug in a -1 and something else comes back, something's wrong. Look at 2. I plug in a 2, I get a 2. Nothing else. I plug in a 3, I get a 2. That's fine. As long as that 2 has a number and that 3 has a number. But here's the problem. 1, if I plug in a 1, I'm either going to get a -1 or a 0. That's a problem. I should only get one number back. If I plug in a 1, it's going to be either a -1 or 0. It's a gamble, and I don't know which one it's going to be. I want to know exactly what's going to come out. So I put in a 1, something else A -1 or 0 might come out. That means it's a no. There is a repeat x. The 1 repeated. That's all you need to put for the explanation. That's fine. For explain, say there's repeat x's. The x's, and make sure to identify which one it is. There are, for x equals 1, there are 2 values. There are 2 y values. That is not possible for a function. Same thing with the table. Look over here. 1, you get a -2. 3, -1. 1, 0. 2, 2, 0, 3. Right there. That's the problem. If we plug in a 1, we might get a -2. We might get a 0. That's a problem. Repeat x's. It's the same thing on the graph, but even easier. You don't have to look. You just look. You have to look. You don't have to look at all of the x's. Just draw your vertical lines. It's called the vertical line test. So for your explanation, all you have to say is, because the vertical line test touched 2 points at a time, it's not a function. If it doesn't touch 2 times, then it is a function. So for example, draw a bunch of lines, and I'm just going to leave it up to you. Does any of your lines hit 2 points? Here, does any of your, and when here they're not points, or they are points, the line represents a whole lot of points. The question is, does any of these lines hit 2 points? For the first one, it sure looks like it. And for the second one, not really. It's hitting 1 point at a time. If it hits 2 points, it is not a function. So this one that I'm erasing right now, not a function. This one right here, it is a function. Again, because if it hits 2 points when you draw your vertical lines, and again, that's the explanation. I did the vertical line test. It hit 2 points, not a function. I did the vertical line test. It only hit 1 point at a time. It is a function. And that is it.